another Draft Physics video production, the redo. Just did this video and it was way too long apparently. It crashed and such. Too much hard drive space, running Linux, and there's different little things I could complain about, but just irritating little things like Linux. It has some stupid file that collects errors, and so if it starts making some errors, it makes this file bigger and bigger and bigger. There's no limit to how big it can get, I guess, and so it ate enough hard drive space to make an hour-and-a-half video too much for this computer. But anyway, just irritating to have to do this all over again. So this is a Sean Carroll as talking at Google. The evil corporation that puts ads on every other website in the universe except their own, of course. Blah, 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 but whatever. I went on a much more elaborate shot at Google. We're paying for this,
Thanks. Great to be here at Google. I've used your service on the internet. And I want to talk about...
Yeah, so why don't you talk about that exactly, this service, this you decide what's on the internet by spying on everybody and profiling everything and giving everyone a different view of the internet. We all don't get to see the same internet. Does that make some sense to you? It doesn't make any sense to me. Would you want the library to do that, the public library, to stack the catalog, based on what you've previously taken out? Annoying.
Quantum mechanics. I'm presuming that, I know there's some experts in the audience, I'm presuming that there are many complete non-experts.
So I have it a little sped up. I did a much more elaborate history of Sean Carroll, a likable fellow, blah, 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 blah. A few years ago made a video pointing out how it seems a real problem in physics that the physicists have this fundamental disagreement about fundamental physics, in the sense that they make up these different stories, Copenhagen versus many worlds being the most dramatic ones. Somehow a new universe is created when every single event happens in the universe. Seems like such a cop-out, such a, the opposite of explaining is to create an explanation that fits everything, because it's basically an invisible man theory. It can do everything you want it to do. That means you can explain every single possibility by just saying they all happen somewhere else.
But probably even the most complete non-experts have heard the phrase quantum mechanics and know that there are many books out there on quantum mechanics. And why in the world does the world need another book on quantum mechanics?
Yeah, another book explaining why this incomprehensible theory is so brilliantly successful at doing absolutely nothing realistically practical. It didn't invent the transistor, it didn't invent anything. All of these things would have been invented by trial and error. The theory itself didn't really help anybody do anything, ever.
And I think that the answer is that I don't like any of the other books, especially because what they tend...
Yeah, so what they tend to do is talk bullshit, and he's going to talk some bullshit. So it's just a different version of bullshit, depending on whether you want to believe in Muslim law or Christian law or Jewish law, and it's all crap.
To do is to emphasize how difficult it is to make sense of quantum mechanics, how surprising and spooky and mysterious it is.
And you can't make any sense of it. I can't even make a sense out of this stupid photon wave thing. It doesn't make any sense. Bent space doesn't make any sense. There's no way to imagine it. There's no way to understand it in real three-dimensional space. So yeah, it makes no sense.
And I admit that there are things about quantum mechanics that are hard to wrap our minds around, but I don't think there's anything intrinsically unintelligible about it.
So that's the part that doesn't make any sense. It's completely unintelligible to tell me something, a single thing goes into something, turns into some double thing, then interferes with itself, and then figures out where to land based on doing all these calculations. That's Copenhagen. His dopey experience is somehow the photon doesn't really have a position. It went to every single positions, and every single position there was a different universe created. So I have his double slit here, and there's an infinite number of spaces in between that double slit. The photon could be in any one of those infinite number of spaces, and therefore there was an infinite number of universes created every single time a photon interacts with a piece of matter, because the photon, because we didn't see it, it could have gone here, or it could have gone here, or gone here, 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 here. You understand, their theory is basically that there is no here in this slit. Okay, this slit is basically just two things. It either went this side or it went this side. No, it went to both sides and made two waves. That's their theory. So there is no it went close to this slit, it went close to this slit, it went down the middle. None of that ever happens. It goes every single possible location. That's their argument. Okay, and those every possible location, like every possible outcome on a roll of a dice, which is 6. So they'll make a comparison between a probability study that might tell you that, you know, there's an equal number of likelihoods that it was in the 1 position or the 2 position or the 3 position or the 6 position, you know, on the dice. That there's an equal number of outcomes for also all of this nonsense. And there isn't. Photons travel actual paths.
Message in my book is that you can understand quantum mechanics, not that you can't. Of course, I'm flying in the face of my esteemed predecessor at Caltech, Richard Feynman, who thinks I think I can safely say that nobody understands quantum mechanics. And I know what he means. You know, he's not wrong. Quantum mechanics, for those of you
well, nobody can understand as a complete theory, as you're just demonstrating, because the odds are, if 10 people have 10 different explanations and they all have the same credibility and they're all in conflict with each other, that is, they disagree, that the reasonable thing to do is say they're all wrong. You know, if there's 100 of them or 1,000 of them, it becomes more and more reasonable, the more variation there is, to say they're all wrong if they're in conflict with each other and all equally credible. Because the odds are 99% of them are wrong at best. That's your best outcome. 99% of the solutions are wrong. Well, why wouldn't you just say, well, if 99% of the time you're wrong, why aren't you wrong 100% of the time? There's no reason not to say 100%.
Don't know is this wonderfully successful theory that we developed.
Successful at nothing. Let's understand it's successful like the gravitational wave theory. You know, say something exists and then create an experiment that finds it. It's so complicated nobody could ever figure out whether you actually did or didn't do what you say you did or didn't do. Same difference. There's no proof in the real world. There's no hard evidence that any of this crap happens the way they say it happens. There's no hard evidence that says the photon doesn't go close to this slit or close to this surface and go through the middle, that each photon has its own little path, and that the laws of probability are that, you know, the average is that, yes, the same number go over here as the same number goes over here, and it all equals out when I send 1 billion photons. But because it equals out when I send 1 billion doesn't mean that each individual photon didn't take a path. Just like when I roll dice, if I roll the dice once, I get a 1, a 2, a 3, a 4, a 5, or a 6. Right? If I roll it 1 billion times, then I'll get, you know, the appropriate number of 1s, 2s, 3s, 4s, all the same number. There's no big surprises. And they're making that into a mystery.
Mostly over the first quarter of the 20th century, that's supposed to apply to everything in the universe, but really becomes manifest and necessary.
Well, obviously it couldn't apply to everything in the universe because it doesn't really relate at all to gravity, and that's a fundamental force. You know, and clearly it doesn't relate at all to anything we see in the big universe. There's no quantum effects. I throw a Volkswagen through a slit, it's not going to do any of this crap. Because the only way it would do some of this crap is if I made the slits like the atomic slits. That is, I made the slits with a bunch of electrons on the outside and a bunch of empty space with big blobs of electrons in the way. And then I crashed the Volkswagen into the something that's effectively like an electron. That is, something that would absorb its momentum and then move back and then reabsorb the Volkswagen. But it's the only way I could make it duplicate it, so it doesn't apply to everything in the universe. It's just silly to say it does. It only applies to subatomic particles that we can't see. We can't see them. Not because it's a rule of the universe that says we can't see them. We can't see them because seeing requires you to interact with something. And there's no passive way to interact with a photon because there's nothing smaller than the photon. And there's not much smaller than the electron except for the photon. So there's no way to passively interact with the photon, the electron either, because there's nothing really small compared to it. And you have to bounce something small off it. You have to interact in some passive, small way to interact with something. And once you get to the small universe, there's no small things to interact with the small things. That's the simple truth. That's the truth that's this whole quantum mechanic crap is built on, is some kind of inability to deal with the fact that some things you won't be able to measure passively without interfering with them. There's no light you can turn on and then turn off and look at them. You know, see, oh, I turn the light on, I can see them. And the same thing happens when the light's off. That happens in our world. In our world, you can turn the lights on and everything stays the same as when the lights were off. You didn't blow everything to pieces. The light isn't a wind that knocks everything down. That's the reality of our world. That's not the reality of the subnuclear world. There's no light switch to turn on and off. And they can't deal with that simple little truth in a rational manner.
We look at microscopic things, when we look at electrons or atoms or very, very small scale things.
We don't look at them. We look at what they do. We look at their effects. And the only way we can usually see their effects is on a mass scale, not on an individual scale, because the effects are happening so fast. So usually it has to be a combined of a bunch of effects that we're looking at over time, because we can't even do the tiny bits of time it's functioning at. The whole universe is moving billions of times faster than we are moving. Our perception is way too slow.
And we can use this theory to extraordinary precision. We can
So more nonsense about extraordinary precision, which just means that if I'm flipping heads and tails and I do it 5 times, my results are going to be, might have a huge error in them, because I might get 5 heads in a row. And I might draw like, well, it only comes up heads. Well, that would be a stupid conclusion, and I haven't done enough permutations. So all they're saying basically is if I flip the coins 1 billion times, my margin of error goes down and down and down and down. The more times I do it, the more places, decimal places, I can get my figures to match. So what? Nothing miraculous in that at all.
Make predictions that have been tested to 12 decimal places of accuracy. Quantum mechanics is absolutely
right. You could do that. You could waste your time flipping a coin. Once you know that it's heads, tails, you know the principle, you know the theory. And if you want to test it to some high precision, yes, you can go ahead and waste your time and create a billion little coin flipping machines and gain your information. But it's completely meaningless information. It's a completely meaningless precision. It's obvious. It gets more precise the more permutations. Obvious correlation.
Necessary to understand why the sun shines or how transistors work.
So none of that stuff is involved. You don't need any quantum mechanics to make transistors work, in the sense that all you need is to understand there's physics. That is, energy goes in, energy comes out. Energy is manipulated by the interaction between energy and matter. And that's all there is. There's forces and there's matter. The forces are corpuscular in nature. They radiate from objects like corpuscles, like little meteors. They affect things like little meteors. All that works just fine. You don't need any of this wooey mush.
Why this table is solid, okay? So why does Feynman say this? Because even though we can use quantum mechanics to make predictions, if you ask physicists, but what's really happening, they don't know. And that's okay. It's okay not to know things.
No, it's not in the context of your arrogance and you're telling us all these things. It's a wave. It's this. It's that. Yet you don't have any real knowledge of it. You don't have any hard evidence of any of that stuff. And all of your evidence can be dissected if you were willing to have it interrogated. It can be demonstrated to be flawed. So unlike physics of old, there isn't a group of physicists somewhere where they can interrogate each other's theory. There's no police anymore. In Newton didn't have the right just to make declarations and everybody accept them. Okay, he had to fight with other people who disagreed, so he'd have to deal with their arguments. No one deals with anybody's arguments anymore. Since the famous Einstein confronting Bohr, and Bohr having no rational response, and they still stuck with Bohr because they wanted Bohr to be right, and they didn't want Einstein to be right. And so clearly that's the end of physics. That's the end of any rational interrogation, because here Einstein rationally interrogated, got a completely irrational response, and physics declared the irrational response the winner. That's the end of the game there. You've just proven it's all mush. It doesn't have anything to do with facts. It has to do with some sort of want for the universe to be a bigger mess than it has to be.
But when you don't know, what you should try to do is to learn, is to figure it out. And as a field, physics has decided not to do that. Rather than taking people who are trying to understand quantum mechanics at the deepest level and treat them as the superstars and most important people in the field, they push them out of the field. They decided that trying to understand quantum mechanics...
Right, so fundamentally you're just basically saying physics isn't a rational science anymore. It's just mathematicians playing with abstract bullshit theories that don't have to have any connection to actual reality. They can just make up any kind of angel force that moves dice. We're not going to try to figure out the variables that are influencing the dice's outcome. We're not going to figure out that it's physically interacting with the physical universe and that's why the dice have a certain outcome. We're just going to pretend that somehow the dice started at no location, they flew around in any location, and then they landed in one place. And we're just going to say, we know it's a probabilistic equation, we know there's only 6 things on the damn dice, we know it's going to come up those 6 ways semi-randomly, and we're just going to forget about the fact that there's an actual process. That the 1s can be made lots of different ways, the 2 can be made lots of different ways. I can throw the dice on the roof and I get a 2. I can throw it against the wall and I can get a 2. I can get 2s lots of ways, and I'm just going to pretend they're all the same way.
At a deep level is not our job as physicists. It's only to make predictions. I think that this is bad. The analogy I like to use is with Aesop.
Let's understand their predictions are superficial and trivial. It's like me understanding the dice roll, and then I go to the roulette wheel and I apply the same kind of physical concept. I say, well, there's only these numbers on the wheel. One of those numbers has to show up, and I figured out there's enough variables in this mechanism of throwing this ball and spinning, and there's so many variables that it's going to be randomized. And there, I've predicted it. I've done something miraculous. You've done nothing, absolutely nothing miraculous. There's nothing miraculous in these predictions. They're merely stating what is overtly obvious and then claiming they predicted something miraculous. They predicted nothing that no one couldn't have predicted.
Fable of the fox and the grapes. If you remember this one, the fox sees the grapes and would like to eat these juicy, wonderful grapes and jumps up but can't reach the grapes. The fox is unable to get to the grapes. So the fox says, you know what? I never really wanted those grapes anyway. They were probably sour.
So this is just exactly what I've been saying about Feynman. So he's basically talking about Feynman, and he's basically talking about the fact that, Feynman was very smart. Feynman was very full of himself. Feynman said, I've thought about this. I've struggled over it for 20 years, since I helped to make the bomb, and I can't figure it out, and therefore you're never going to figure out the answer either, so we might as well just give up on figuring out why it comes out this way. Why does the dice come up number 1? And then number 2, and all I did was throw it and randomize the environment it's hitting. It's some unknowns, a bunch of unknowns, and I can't figure them out, so forget about trying to figure it out. Forget about trying to figure out the mechanism, and just pretend there is none, when there's clearly a mechanism and they're just running away from their obligation to find it. The rational thing to do would just be saying, yes, it's a mystery, we got to solve this. And instead, they basically said they're so arrogant, they're saying it's unsolvable because I couldn't solve it. I couldn't find the pathway through the maze to the center, and I'm really smart, so you have no chance. And that's all they were saying. They're just so full of themselves.
The fox represents physicists, and the grapes represent understanding quantum mechanics. We used to try very hard to understand quantum mechanics, and we subsequently stopped, and I think that was a mistake. I
don't think you ever tried very hard. I think you always were, like Bohr, trying to bend it into some God theory, some kind of bullshit. This whole jumping so fast to the wooey explanation rather than the simple explanation. Again, there's 2 slits. They're surfaces. Right in front of them, they have all the evidence they need. Again, I could just keep reiterating this. They use the 2-slit as this nail-in-the-coffin evidence of a wave theory. Yet, if you just examine the slit experiments, they're evidence that it can't be. The single slit in waves doesn't create interference. The double slit in photons is creating two patterns, not one pattern. The wave in 3 or 4 or 5 slits is creating individual images at the location, which a randomized theory can't do. If you randomize, if you just say it doesn't matter whether the photon's here or here or here or here, that it's everywhere, you can't project an image that way, especially with interference, where you're not explaining where the photon went or it got annihilated. You can't project an image that way. The wave theory doesn't work. So, I mean, the evidence is there that this is not true, that it is in fact a straight line path that this force is traveling, and that something deflects that path. And the rational explanation is the slits are made of matter, and that matter is electrons on the outside. That's what an atom is, electrons on the outside. So the surface has to be electrons, clearly. And that photons interact with electrons. We already know that. They change. The electron moves and the photon is readmitted. We know that's how it works. So why wouldn't we expect the direction of the photon to change? Of course it would. There's nothing. You don't need to go beyond the physics, the physical explanation. You don't need any of this nonsense that the photon is everywhere or nowhere. That it behaves in every way in its outcome as if it drew a straight line. You can draw the straight lines. It always works. Straight line always works as a solution. And yet they want to draw these crooked lines.
So let me tell you how we got to quantum mechanics. This is a fake version of the history, but it gives you an idea. So by 1909, we had this picture of the atom, which is the same cartoon you will always see when people talk about atoms. I think it's literally the logo of the Atomic Energy Commission.
Well, he calls it a cartoon, but it's fundamentally true. In terms of a diagram, it makes sense that the protons do seem distant from interaction, and the electrons seem, ready and able. So it seems clear that the electrons are easily accessed, the proton is not so easily accessed, so it does make sense to say one's in the middle, one's on the outside. And it also explains how the two charges can be in a balance with each other, and that would be the balance. So it makes sense in lots of ways. Now, orbiting doesn't make any sense in my opinion. Having electrons orbiting and then being shared in some sort of figure-8 nonsense doesn't make any sense, because that's not going to be a very binding thing. So they're actually physically shared in a real position. They have real positions in space, but because they don't understand what electrons are, they think they're spinning and doing all kinds of nonsense when all they're really doing is wobbling in space, as I've explained, because they're exchanging. Okay, they absorb energy and release energy, and through that process they have an uneven balance, and so they're either going this way or they're going that way. They're either going this way or they're going that way. They're either going that way or going this way. But they can't just do this because there are odd number of seats in their boat, as I've explained. And that has an implication that the fundamental structure of the electron, the energy it holds, can never be in balance. It itself can never be in balance, because there's only 5 seats in the boat, and there's no way to make 2 and 2 or 3 and 3 out of 5 seats. You're always going 3 that way and 2 that way, or 2 that way and 3 that way. You're always going to be imbalanced.
The Nuclear Regulatory Commission. There's a nucleus at the middle of the atom, which we now know is full of protons and neutrons, and there are electrons orbiting around the atom, okay? The problem...
Okay, yeah, see, the problem is you've never taken that simple diagram and said, well, what does that mean for surfaces? What does that mean for the surface of anything I create? Anything, any matter I put in any location? What does that mean? Well, it means the electrons are always going to be on the outside. Always.
Is that even though this is consistent with certain pieces of data, it can't be true as the final answer, at least according to the standards of classical Newtonian mechanics.
So again, this idea that it can't be true because classical mechanics says it can't be true. No, it only can't be true if you don't, I can put space shuttles on the ground and I can say it can't fly, it can't get to the moon, it can't go anywhere. Well, it never went to the moon, but you know what I mean. And I could just say, well, yeah, it can. If I put a rocket on it, I can get it anywhere you want it to go. I mean, it's easy to make it can. So again, he says it can't, but it only can't because they don't have any theory of energy. They don't understand. They think electrons actually are producing something, like there's something the electrons emitting in some way. It's making it and it shoots it out as some kind of thing. When the fact is, just like the earth and gravity, just like the sun and gravity, there's no using it or consuming it or making it. Okay, the sun doesn't make gravity, the earth doesn't make gravity. It's obviously a force coming from somewhere else. Because there's energy, things are moving, and they're moving because of this effect, and this effect can only be coming from something else. The pressure has to be coming from the outside, because there's no evidence that anything on the inside has changed.
Because these electrons zooming around in orbits should be emitting electromagnetic waves. When you take a charged particle like an electron and you shake it in any way, it has an electric field radiating out in all directions. So when you move the electron, the field adjusts.
Right, so this is like saying I have a light bulb and I move the light bulb. Well, you're moving the field. That's exactly what I've been saying. The field isn't being created by the movement. The light doesn't turn on because I'm moving it. The light's always on and I'm moving where the light shines. That's what's happening. Now, they're saying that I can't explain why the electron is on, why the light bulb, the electron, is on. Well, I can explain it's on because it's on just like something else I might see, because stuff is reflecting off of it and I can see it. It's doing the same thing this light bulb is doing. It's shining at me. Right? You see the reflecting, this light? Look, there's light coming off of this thing. How's it doing that? Well, it's doing it because it's reflecting. That's all the electrons are doing. That's all protons are doing. And the truth is they reflect exactly opposite things. So whatever reflects off electrons passes through protons, and whatever reflects off a proton passes through an electron. And there you have the most fundamental action in the universe, which is charge. And you just explained it with a simple mechanism. A mechanism so simple. I shine one kind of light on this battery, and there's no shine here. This is dark and this is shiny. You get the exact opposite reflection. And it's that simple.
When you move it up and down, the field waves, and we see those. That's where
So the field doesn't wave. If I move a light bulb up and down, you don't sit there and say the photons are waving. No, you understand they're being emitted from one location, then they're being emitted from another location, they're being emitted from one location, then the other location. There's nothing waving. There's no bullshit going on at all. There's just, if it was a gun, if it was shooting water, I wouldn't say the water's waving because I'm moving the hose.
light that we're seeing right now comes from vibrating electrons.
So the light we're seeing right now, so the very idea that they don't understand that, yes, that's exactly what gravity and everything else is doing, and it obeys the same exact rules. Gravity does exactly what a light bulb does in terms of creating the inverse square law. It's, you know, the fact is that it's radiating straight lines and they're spreading in both dimensions at the same rate, and that's the inverse square law. They're all obeying the same circular spherical symmetry arguments, and yet they don't connect these dots. They don't add 2 plus 2 plus 2 and come up with the right answer here.
So these electrons that are moving around in circles should be emitting light, and that means they should be losing energy, and they should spiral into the nucleus.
So there's no reason why they have to emit light. So again, that's his argument, that somehow they have to emit something. So what he's saying is that, you know, in his one example, he's saying they're creating a field effect, and the field effect goes with the electron. It changes if it's affecting the universe over here. If I move the electron over here, then it's changing the universe over here, and the change it was doing over there isn't happening anymore. So the light moves with the electron. And again, he's saying the electron has to somehow produce that, when clearly all I have to do is put the electron here, okay, and it reflects force created by something else that does have energy. And the something else that does have energy is the universe, as the cosmic background radiation demonstrates. Lots of energy flying around the universe, and it's reflecting off protons and electrons, and just doing it in the opposite way. And that simple fact, that simple mechanism explains everything.
Nucleus of the atom. And you can calculate how quickly that should happen. It's about 10 to the minus 11 seconds, which is a very short period of time. So in other words, according to the rule... So in other words, according to their straw man argument, where the energy has to come for this thing to be visible now,
for it to shine photons at you right now, it has to lose mass. That's what they're saying. There's no other way to explain it. This thing can't possibly be visible to you. It can't possibly be affecting you with a force, okay, that affects your retina. There's no possible way it could do it unless this battery got smaller and smaller and smaller and used up its energy to do it. There's no way it could do this forever, okay? Can't be visible. Right, of course it can, as long as the light's on. As long as there's a force in the universe reflecting off of it, it'll keep doing this. It'll keep shining. That's the fact.
Of classical mechanics applied to the Rutherford model of the atom, all matter should be dramatically unstable. You and the chair you're sitting on and this cable and the Earth itself should collapse into a point in a tiny fraction of a second.
Right, only if you believe the energy has to come from inside of the electron. That's it. So only if you narrow the possibilities to their straw man argument of what conventional physics would require, is that true. So it's only true if all light has to come from the thing that's making the light. If you reflect the light or reflect a force, then they can't imagine that as a possibility. They can't imagine this concept. Force reflecting off something. It's beyond their imagination, they're saying. It's beyond what a conventional theory could imagine or come up with. The idea of light reflecting off of something and looking like this is a source of radiation. This is not a source. That light bulb over there is the source. This is not a source.
That prediction does not fit the data, so we need to do something better. There was a many idea.
Yeah, so nonsense. Straw man as an excuse to just go into wooey circles, to create your toroids or some other nonsense, some bizarre, strange, insanely incomprehensible mush-averse.
Was batted around. What we eventually hit upon was, don't think of the electron as a point particle in an orbit. Think of the electron as a wave. In particular, we dubbed this the wave function, which is the most boring, uninspiring name for the most important.
Well, yeah, as well, and it's not the most important anything. It's the biggest mistake you could possibly make is to draw some stupid conclusion when there's no evidence of anything waving. Again, if I move this object around, okay, are you going to say the photons are waving, the energy's waving? It's not waving. The location from which it's being emitted is changing. That's all that's happening. My monitor's got to turn off. There's always something here. I'm having such a bad day. Bad start to it anyway. Let's see, maybe this will work. Yeah, maybe I don't have to hit anything more fancy than that. Well, we'll see. If it turns off, I just have to turn it back on again.
Thing in all of physics, the wave function is the idea that rather than being in an orbit around the nucleus of the atom, think of the electron as being described by a wave that is spread out around the atom.
So again, it's just making up stuff. We know spherical symmetry means that a radial force, like Maxwell's drawings, it'll be the same equidistant. That's what a sphere does. And again, if it's spreading in 2 dimensions, that's the inverse square law. So it creates everything you need. There's no necessity to create any idea of some sort of wave moving, when all you can just say is that, yes, if I shoot a bunch of, if I have a gun that has 50 chambers and I fire the pin all at once and every chamber fires and the bullets all leave at the same time, that equidistant from my center, that each one of those bullets will be the same distance away. So what? It's not a wave.
And just like a violin string that you pluck in different ways, a string that is tied down at both ends has the fundamental frequency that it can vibrate at, and then there are overtones, harmonics that it can vibrate at.
Right. So where's anything tied down at both ends? There's no comparison to standing waves here at all. It's just mush. There's no way to imagine that. I'm imagining an electron and it's waving somehow. No. It's just nonsense.
In different ways. The point is that there's a discrete set of different ways it can vibrate. Likewise, if you think of the electron as a...
Yes, and there's discrete rules. So the whole point is a force has to go in. So if I just gave you this boat rowing analogy, and I said there's a boat, and it's got these 5 seats going in all directions, okay? So it's a round boat, and it has 5 seats going in any direction, and they all face out or they face this way. So they're all facing in the direction they're going to move. And you understand there's a bunch of rowers, swimmers. Okay, they're going the speed of light, and they can jump in the boat. And the boat never goes anywhere near the speed of light because, they're rowing against each other and all that kind of stuff. But obviously you will go in the direction. If you have 3 rowers going this way, this way, and you only have 2 going that way, you're going to go a little bit this way. Obviously, if you have 3 rowers going that way and you have 2 rowers going that way, you're going to go a little bit that way. So that means this way and that way is going to equal that way. And then you can just add them all up, and there'll be a direction the electron will travel. And that direction is going to constantly change as rowers jump in the boat and jump out of the boat. And if I change what kind of rowers are in the boat, that is, I turn a light bulb on, it means a whole bunch of rowers are going more this way, and there's less rowers going this way, then more are going to jump in the boat this way, and I'm going to change the direction more this way. It's that simple. You can make it that simple, and it works. You don't need any of this wooey wave nonsense. Any of this spontaneous, unaccounted for action. All the actions have a cause. The boat isn't just randomly moving. It's moving because the force is changed any one second, but it's just as real a change as if I'm flipping coins. I go 3 heads in a row, and then 2 tails, and then 5 heads, and then whatever. And I know over time it's going to be balanced, but at any one moment there's going to be imbalance. And any imbalance in one direction is probably going to be undone, inevitably be undone, by imbalance in the opposite direction. Because the fact is, when there's when there's 5 rowers going this way in my boat, that means there's 5 going that way in the water swimming. Okay, if I have 5 extra going one way, it means there's 5 extra going the other way in the ocean. Or in somebody else's boat.
Wave, rather than as a particle, there's a discrete set of shapes that wave can have in the atom, and there's a minimum energy shape. So rather than just spiraling in to the center of the nucleus, the electron goes to its minimum energy configuration, which is still spread out. It's the shape in the upper left.
So it's just like you saying this is my minimum energy position on planet Earth. In the sense that the pressure pushing up the Chinamen are denting the Earth on the other side. That dent travels through the Earth, and it creates enough pressure to push me back up against gravity. And I do the same thing to him, and blah, blah, blah. And we're yin-yanging here on the surface of the Earth, and this is my minimum energy. I'm trapped between 2 forces, gravity pushing me down, the pressure of the Earth pushing me up. It's really gravity against gravity. It's gravity going this way, and then gravity going this way, and the 2 are equalized on the surface of the Earth, and I'm stuck in this position. And to get me out of this position, you have to apply a force. And the point is that you have to apply a lot of force for me to escape the rebound effect. The fact that the force is still always active. And so you have to keep putting new rowers in the boat to get the boat out of the predominance of rowers coming in one direction. So we'll go against the tide. You've got to put gas in the motor and turn the motor on to go against the tide, to go upstream.
Here, spherically symmetric. These other shapes are higher energy versions of the wave function of the electron, and then it just sits there forever. And if you remember high school chemistry, you were tortured by pictures of electrons doing these things in the various orbitals that they...
So you could understand that if you could actually take a magnet and rip the poles off and have a monopole, a negative and a positive, that it would be really easy for you to arrange a bunch of negatives and positives in certain geometric shapes where there would be balance. That is, I could put two north sides here, and then I could put another north side here, and I could be balanced perfectly between these 2 in terms of the repulsion. And then I could put a positive one here, and then I could pull it in closer, and it would be in tension between these 2 and the pull towards here, and it would be a tension here. And the only way I could really lock it out of this tension, okay, is I'd have to apply sufficient energy to break it free all the way. But I could wobble it really easy. I could wobble it in this position by changing how much this is. I could put the proton further away, closer. I could make this thing wobble in lots of places, and it would sit there like it was tied with strings. But there aren't any strings. The strings are the tension the strings are really just hoses. And so you can imagine a bunch of fire hoses, right? And you could have 3 people and they could shoot fire hoses, and they could keep a little duck, just sitting, on a puddle of water up in the air. And they could move the duck around. They could do lots of things with the duck, and the duck wouldn't go anywhere. And to really change the duck to knock the duck off, you have to do it with enough energy to overwhelm the fact that you're moving into a force that's stronger, as you get closer, or the force gets weaker as you get further away. And so there's a certain binding energy. So you have to add a certain amount of energy in a certain way to free it. And because it has this resonance things, because there's a certain distances involved, that means you have to constructively interfere with your energy. So you have to push your energy in a certain way, like a tipping point. If you want to tip something, you have to figure out its rocking motion and always add the energy when it's moving in one direction. And that way you can increase the tip, increase the wobble, and knock the thing over. Same exact principle. And so electrons have a comfortable position, and you have to make them uncomfortable. And a little bit uncomfortable won't work if you want to break the system. If you want to break it, you got to hit them with enough energy to knock them over.
Could be in. And so this became a way of thinking about why matter is stable. Even better, a couple of years later, Erwin Schrödinger came up with an equation for how these orbitals, electron wave functions, actually behave. And I give you the details of the Schrödinger equation, because I know you all want to go off and solve it in your spare time.
Yeah, it's got a bunch of H bar, H, it's got a bunch of constants just manipulated over each other, and the key factor being time. Okay, and the time means that it's all about this idea of a tipping point, in the sense that you have to regulate the frequency at which you hit something to be able to constructively keep adding energy to the system. And if you don't have that timing thing right, then the whole thing isn't going to work. There's no energy.
People here at Google who spend a lot of time solving this equation on quantum computers. And you don't need to know the details of the Schrödinger equation if you are not a quantum mechanical expert. What you need to know is that there is an equation, okay? So physicists love equations for good reasons. It's because you can go...
Yeah, for not good reasons. And it's just hiding the effect in a bunch of complicated terminology, rather than just saying what it is. We know there's variables for the 2-slit experiment. There's the frequency of the light, and then there's the width of the slit, and then there's distance to the target. And those are the things that are going to decide what you see where. And those are the rules. Those are the variables. And you understand, why does it matter how close the slits get together? What happens when I move the two surfaces closer together? Well, what happens is the odds of you going really close to a surface increase. That's the obvious change that happens. The closer I make the slits, the odds are you're going to be closer to one of these surfaces. The further away the slits are, the less likely you are to be really close to a surface. That's what's changing. So instead of understanding mechanically what's changing, they've changed it into some abstract notion that some abstract thing is changing the experiment, when something quite obvious is changing the experiment. You're increasing the likelihood of contact near a surface.
From the original idea, the electron is a wave around the atom. Now you can just apply it widely. You can apply it to any other circumstance. You can take the wave function doing anything.
So this is nonsense. You can, but it won't do anything. I can apply it to a Volkswagen. Say a Volkswagen has a frequency, and that it's a timed interaction, and then I can put it through 2 slits, and guess what? It's not going to do any of the stuff that a photon does, because it's not the same circumstance. It doesn't have the same circumstantial variable, so it doesn't apply in any way whatsoever. There is no probabilities, because there is no surfaces encroaching on the Volkswagen. This is all just nonsense.
And you can let it evolve. You can solve this equation. In words, the Schrödinger equation says any one wave can be decomposed into different energy parts, and every energy part evolves at a separate rate. So the energy of the wave is proportional to how fast it...
So again, that's just nonsense. So this idea of making it proportional is more of a de Broglie thing, of establishing somehow that momentum, that is your speed and your mass, has something to do with your frequency, when those two things are different functions. Frequency is different than momentum, and they've basically said because it works with photons, because photons at a frequency have some special momentum, that is because there's a tipping point, which means that If I hit something too slow, right, I get nowhere because it rebounds, right? So it always goes back to the neutral. I hit it, it goes back to the neutral. I hit it, it goes back to the neutral. Then I can say that somehow this frequency has zero momentum because it doesn't make the magic thing happen. But then again, if I hit it with a little faster frequency, so it can't rebound all the way, and then I hit it again, and it can't rebound all the way, and I hit it again, then I tip it over. So now I say that this frequency is the magic power frequency. It has momentum. It has authority. It means something. When no, all the difference is very circumstantial. They both have energy. They both have the same. They're bullets, and all you did was change the rate at which you fired the bullets. It doesn't mean there's anything different fundamentally. There's only something different in the timing, and timing's important to electrons, or things you're tipping over. And that's it. But they've turned this into some sort of mystical, magical thing when it's just a tipping point argument.
That's the Schrödinger equation. That's the entire thing. And so this equation still, suggested in 1926 is still right as far as anyone knows. It's one of the fundamental rules of nature.
As far as anyone knows, as far as blah, blah, blah. Yeah, yes, you have no real hard evidence that it has any significance or meaning whatsoever, except it's a probability equation. And so it's like rolling the dice, and you're just saying what's the probability of knocking it over, and you have certain rules for knocking things over. But again, they change the equation to fit the different circumstance. So it's not like there's one universal equation and it always works. They have to change what they're going to measure. Like in the two-slit experiment, it's the distance of the impediment. In the single slit, it's the width of the slit. So they change the variable. Well, what's the connection between those two variables? Well, it would be the distance between the surfaces, right? The distance between these surfaces is the same as the slits, the distance between the surfaces. So again, the surfaces are what's causing the effect clearly, obviously, overtly. Okay, and the reason why, and it's sort of a proof of that, is that you can use the same variable. The distance of the surface works as the variable. And so the equation fits because of the fact that it's about the surfaces. It's not about anything else. How far apart are the surfaces? That's what's changing the effect.
Sure. So you might think that we're like triumphant, that quantum mechanics is basically done, that we know that now electrons are not particles, they're waves, this is the equation they obey. That's what you want in a good physical theory.
Yes, and that's all their assumption and presumption and jumping the evidence and drawing a conclusion that was unnecessary to draw. And so that's their downfall.
Understanding of what nature is and which equation it obeys.
So again, it's not about obeying equations, it's about understanding the variables that the equation is made out of. So it's just an equation is just a formalization of what you know. It doesn't tell you what you don't know. And so the variables are once you understand the variables, then you understand what's changing when you're rolling the dice. So understanding the surfaces you're hitting and the angles at which you're hitting them and the momentum, then you can figure out what the dice is going to be. But obviously you can't figure it out when there's 10 million interactions. I mean, atomic interactions.
Problem is, the data don't stop there. So this is a wonderful little image of a chunk of uranium in a cloud chamber. Okay, so a cloud chamber has some pressurized gas in it that when a charged particle moves through the gas, it ionizes.
Right, and the reality is even more clear than this picture. This picture is showing you the damage after the meteor shot through houses and flew a bunch of pieces of the house into the air, and you're seeing the reflection of the piece of the house wobbling through the air. So you're seeing a level much different than the actual level of the meteor that shot through. You're not seeing the meteor, you're seeing the meteor destroy a bunch of crap. And you're seeing that crap move in the wind. So the variability you're seeing is all synthetic, and it's the fact that the little thing that caused it was moving in a dead straight line. So these are like bullets flying out of this thing. And there's a clear symmetry, and there's a clear inverse square law appearance that it comes from a small center, it all moves out at angles and over time, and they spread in both directions. And that's the inverse square law. So this is showing you the inverse square law. It's showing you why there is an inverse square law, because there's spherical symmetry, and there's everything from a small location has to diverge to get to a large location. And that divergence is the nature of the fact that you can't have the energy coming out in parallel lines and then be symmetrical. Can't work. So it has to be diverging.
The particles around it, and it creates a little trap, okay? So if you have a chunk of uranium, it's radioactive, it will actually emit electrons and alpha particles and things like that, and you can use the Schrödinger equation.
And you can see their path, and you can see the fact that they're not going to Venus, they're not going anywhere else, they're going on a straight line path, and that every path is unique, and over time every path will be taken eventually. And just like the dice, it'll roll a 1 or a 2 or a 3 or a 4. It'll come out here, it'll come out here, come out here. So yes, the piece of uranium has a lot more choices than 6 dice faces, but if you just did it based on the 6 dimensions, I mean subdimensions, forward, back, left, right, up, down, you can see that over time you'll get just as many ups as downs, and just as many rights as lefts, and just as many forwards as backs. So the 1 will come up just its right amount, the 2 will come up its right amount, the 3 will come up its right amount, the 4, the 5, the 6.
To say, well, what does the wave function of the emitted electron look like? The answer is, it looks like a spherical wave. The electron wave function comes out in all directions, more or less.
So obviously this is just a consequence of spherical symmetry. If you shoot bullets from a sphere in all the same directions, the bullets will travel the same distance at the same speed, and they'll all be the same distance from the origin at all the different locations, and you could draw a line and you could, that's a wave. It's not a wave. There's nothing, it's not fundamentally made out of wave. It's not fundamentally a wave in any way. It's a bunch of discrete individual bullets flying away from the Earth or flying away from any spherical object. And that's all it is. There's not a wave of satellites orbiting the Earth.
Equally. There's details, but that's the basic story. But then you look at it, you never see an electron coming out in all directions equally. What you see in this picture are straight lines, trajectories.
Right, and what you see in Maxwell's drawings of charge is straight lines, trajectories, the amount of force, the bullets, the quanta, the stuff, the crap that makes everything happen is leaving in straight lines and obeying the inverse square law. You see exactly this effect. That's what a charge is doing. It's reflecting, okay, energy exactly like that. And that's what this battery is doing. Exactly the same thing. The light hits it, and some of it bends, goes this way, this way, this way. From every little piece on this surface, it's going all kinds of different directions at any one time. And it ends up doing, over time, exactly that. It ends up proportionally creating light based on its shape.
As if the electron is a particle again. What's up with that? We still have not answered this question. What's up?
Yeah, yes, exactly. You evade the obvious. It's sit there and plainly stating to you what it's really made out of. This is a straight line force made out of discrete bits. It duplicates exactly the same inverse square law math. It's doing exactly that. Even though we can't see it, we can see it's doing exactly the same thing. The little bits of charge, the little electrons are doing exactly the same thing as what the uranium is doing to electrons. Okay, electrons are behaving exactly the same way in their part of the universe. They're emitting the same kind of force, and they're emitting it because they're reflecting it, because they're just reflecting what's in their environment. And the proton reflects one way, the electron reflects the opposite way, and that's charge, and that's why they attract and repel, and it explains everything. And you don't need any of this wooey nonsense.
With that. This is the sad part about the modern understanding of quantum mechanics. So what people said...
So again, it's sad. What does that mean, sad? No, it's pathetic. It's not sad, it's pathetic. It's pathetic that you have every bit of evidence that your wave theory doesn't really work. If you examine the slit experiments, they tell you it can't be the explanation because you can't transmit images with your randomized bullshit. So it fails, and it fails to have any real hard or conclusive evidence anywhere, and yet you've drawn the conclusion, and there's no reason to draw any conclusions. There's no reason to go there and say you're going to sit there and break quantum mechanics, essentially, by creating some kind of fake idea of a fake wave that moves in discrete directions. It just doesn't make any sense to say something, the force went everywhere, and then it calculated what the shortest path was. What a bunch of nonsense.
was, look, it looks like the way that electrons behave in their wave functions is different when you're not looking at them, like when they're in the nucleus, around the nucleus of an atom, versus when you are looking at them, like when they're in the bubble chamber or cloud chamber, okay? Now, surely that can't be the final answer, but what the strategy adopted by physicists in the 1920s is, yes, that's the final answer. So they invented an idea called the collapse of the wave function. They said,
right, which is just doesn't make any sense, but you're collapsing it with an interaction. So it's just another concession that we can't see these things. We can't throw any photons at them. We can't throw anything at them to look at them. We can't turn a light switch on. A light switch goes on. We see where it is. Turn the light switch off. We don't see it. But we know it's exactly the same thing. Nothing in this room is going to be changed by me turning the light on and off. People concede that. Okay, it's all too massive, too heavy. It's too rigid. It can't be. It's everything. You might as well just say the light is a passive interactor, because it's not going to be able to create enough energy to cause a significant change in any of the shapes that exist. So turn the light on, same difference as turn the light off. Nothing changes. But we know on the subnuclear level there's no light bulb weak enough that I can turn on that isn't going to affect electrons and protons. They're fundamentally affected by forces. Well, the photons aren't, but I mean the electrons clearly are. And the electrons are the only way we detect photons. We can't see a photon in any way, shape, or form. The only way you see light is for it to terminate by moving an electron in your eye. You never see light. You never see a photon moving somewhere, like in a laser beam. You see the photons moving. Well, you really don't see the photons moving, because the ones you're seeing are photons that were deflected into your eye and terminated. They never got to the destination. The laser beam you're seeing, none of that stuff, none of that beam ever got to the destination. That's all light that didn't go there. That's all light that didn't travel the straight line, because it got deflected off of a piece of matter. It's just so obvious what the truth is here. So again, there's no such thing as a passive interaction with a photon or a passive interaction with an electron. When you turn their light, when you turn light on that you can see them in, that light wipes them out. It's like turning on the 500-mile-an-hour wind. It blows out all the pieces. It's like having a switch that just blows everything off the desk and blows everything out of the room. Clearly, the light on, the light off are not the same conditions.
Sure, wave functions for electrons or whatever, they obey the Schrödinger equation when you're not looking at them. But when you measure a quantum mechanical system, its wave function suddenly and unpredictably changes.
Right, and it's not even sudden or unpredictable. So that's another nonsense, right? There's no spontaneous. It takes time, and clearly it's explainable, because they're the smallest thing in the universe. There's nothing smaller. I can't reflect something off the smallest thing in the universe. Okay, the photon. You can't bounce something off of it like this. You can't bounce light off of it and then see the light and say, oh, look, there's a photon. You can't do that. All you can do is hit it with another battery. I have to hit it with another battery to see it. And then even then you can't see it, because it's all kinetic interactions. So you won't see anything happen. The truth is, if two photons interact with each other, right, it's going to look, the universe will look exactly like if they didn't. If they hit each other and reflect, it's going to look exactly like if they missed each other altogether. So you won't even be able to tell the difference. Even if there was a light you could turn on, you couldn't see anything, because there's no change. You're not changing the system. And so if you can't change the system, you can't see with what the thing you did. If you can't tell the difference between missing the photon and hitting the photon, then there's no point in hitting it, because you won't be able to tell the difference. Anyway, so you couldn't see them. Even if you could shoot photons at photons, you can't see photons with photons, because you can't change anything fundamental, because they're purely kinetic.
And rather than predicting exactly what's going to be able to happen, you can predict the probability of different things happening. And the probability is largest where the wave function was largest. And after the measurement has
So again, this is all just probability, and again, this is all just, you could do the same analysis for a roulette wheel or for a rolling dice or for anything, and all they're basically saying is we know what outcomes are, we know what the standards are to apply in the equation, and so we can predict that there'll be just as many ones as there will be twos, and there'll be just as many threes as there are fours. That's hardly remarkable. You could do that without even trying. Without a book on quantum mechanics, I could walk into the gambling house and I could figure out the odds just by watching.
occurred, the wave function changes to be localized where you observed it. So on the left here, you have a picture of a wave function that might be all spread out for an electron. You imagine measuring the position of the electron. Its wave function collapses somewhere. And if you looked at it again...
So again, there's no way to look at an electron without hitting it with a real force. That is photons. Photons move electrons. That's rowers jumping in the boat. So you can't see where the boat is by putting rowers in the boat and then moving the boat and then say, I saw where the boat was. You won't see the boat where it was because by putting rowers in the boat, you change the direction of the electron. So obviously you can't rationally predict where the boat's going to go if you're moving the boat.
Right away, you would see it in the same place. So this is the attempt to understand why electrons are all spread out in wave functions when you're not looking at them, but look like particles when you do look at them, because...
No, they do what they're doing. That is, the force moves in straight lines unless you interfere. And obviously, if you're going to try to look at an electron, you're going to interfere. So it won't look like it was going where it was going because you've changed the direction it's going, quite obviously. So there's no consistency. So you're breaking the probability by adding a new variable. The dice rolled 1 and you flipped it. You just got another, you're interfering. So you're changing the outcome. It's like you let the dice land and then you take your finger and push it. I mean, you're changing the outcome.
The act of measurement is something special. It really does something to the particle in a particular way.
So again, there's no measurement. There's certainly no passive measurement. There's no me just seeing reflected light from the battery and I'm not affecting the battery at all. The light isn't going to affect the battery in some significant way at all. There's just it can't have any impact on the function. It can't escape the gravity, therefore you don't have any effect. Like the ultraviolet, I like the infrared light not being able to kick out the electrons. Just doesn't matter how long I wait, it's not going to happen. It doesn't do it.
So this is what's called the textbook or Copenhagen interpretation of quantum mechanics. This is what we teach our undergraduates. I'm not going to reveal the truth. This is what we actually tell our kids. This is what I was told. The rules of quantum mechanics, according to this way of thinking, come in two groups. There's one set of rules for when you're not observing the system. Those rules say that the electron is described by wave functions, or whatever quantum system, there's a wave function, and that wave function obeys the Schrödinger equation.
So again, there's just a probability of outcomes, and that everything usually has a connection between proximity. So if you're in the middle, you can move closer to the left or closer to the right, and that makes you closer to the left or closer to the right, or further from the left or further from the right, and it's always proportional. So the fact that stuff has proportionality, especially on the small scale, and it always turns out to be spherical or geometric in some simple way. It has a simpler geometry, so the variability is kind of obvious. It's like polishing glass. Okay, it goes from 16% reflective to 15 to 14 to 13. It progresses in a sequence, and it's a very regular sequence. So it goes from 16 to 0, and then back to 16, and back to 0, and it's a circular scale. And that's all Feynman was talking about, is all of these things have to fit a probability that is basically like a clock. It just goes around and cycles through the same probability over and over again. And that's all the dice are doing. The probability of 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. There's no 7.
That's exactly in parallel with the rules of classical mechanics. In classical mechanics, there's a system and it obeys some equations, and that's it. Those are all the rules. In quantum mechanics, you have those rules, but then there's extra rules for what happens when you measure or look at or observe the system. You can only measure certain things. When you do, the wave function collapses, and the best you can do is to predict the probability of a certain collapse.
And again, the explanation is nonsensical in the sense that they're saying somehow the measurement had something to do with it. No, measurement only had something to do with it because you're not measuring, you're interfering. You can't not interfere with the small system, you can not interfere with big systems. So big systems, you can not interfere with them. Small systems, you can't not interfere. That's the only rule here. That's the rational explanation for the mystery of the results. There's nothing mystery, because there's no mystery in the fact that you never measured anything. You interfered.
That's the Copenhagen interpretation. This is clearly unacceptable as a fundamental theory of nature. I mean, what do you...
Clearly unacceptable, he says of Copenhagen, when he's going to propose this even more unacceptable nonsense that this battery is reflecting light in all different directions, and in a million new universes were created by this battery. And as I'm wobbling it, it's a billion new universes. Zillion new universes are made now because I've given it a more range of motion. So I'm creating an infinite number. It's an infinite number, actually, because there's an infinite number of positions this battery can have, theoretically. Theoretically. Almost infinite. Well, there's at least a... It doesn't matter. The permutations of the angular differences in 3 dimensions would essentially equal infinite, I think. But anyway, it doesn't matter. It's a preposterous number of new universes created just by me doing this. Nonsense. Absolute nonsense.
Talking about, it's fine for making predictions and building things, but it's clearly not the final answer. This was the point of contention in the famous Bohr-Einstein debates in the 20s and 30s. Niels Bohr was a founder and defender of the Copenhagen...
Right. Einstein asked simple question: is the moon not there when I'm not looking at it? I mean, it's silly to think that this matters. Me looking at anything, me interacting. The moon's the moon. It's there. Lights on, lights off. Doesn't matter. Moon's there. This is just all gibberish. That something needs to be interacted with for it to know where it is. Everything knows where it is. Everything is somewhere. And it's just bullshit to say that the moon isn't there because none of the particles that make it up are there, and nothing's where it is. Nothing's in its real position. Everything's in some superposition of every position in the universe. It's just crap.
Copenhagen interpretation. Einstein said, look, that's fine as far as it goes, but clearly it has not gone far enough. We need to look harder. This is why the title of my book is Something Deeply Hidden. There's something else going on.
No, there's something deeply obvious that you're missing. Which is you stepped right over the rational explanation. For some reason, you stepped over the edible meal and went to the dog's anus for your dinner. I mean, it's just clearly obvious that you're trying not to fall on the truth. The truth is right there in front of you. It's showing you the truth all over the place. Maxwell drew you the truth, and you're still trying to find something else. It doesn't make any sense.
Haven't yet explicated. And Bohr and his friends said, no, it's fine. Don't worry about it. And Bohr and his friends totally won the public relations battle.
Right, and even though they made an incomprehensible reaction to Einstein's simple question, is the moon not there when I'm not looking at it? And they had no rational explanation, so they published a completely irrational explanation, and when they republish it in the wrong order. The pages are in the wrong order, and people can't even figure out the pages are in the wrong order. That's how incomprehensible the explanation is. So imagine writing a book where it wouldn't matter whether I put the 400th page where the second page is and the second page where the third 300 page is, and somehow you'd read the book and it would be just as coherent. No, not very probable, is it? No. That's how bad it is. And the majority of people chose Bohr's side. Why? Because it's religious wooey crap. And Einstein's arguing for a clockwork universe. Nobody wanted that clockwork universe. Now, let's understand that Einstein is just as guilty as them, because in figuring out, in pondering gravity, he came out with a completely invisible man bullshit explanation of somehow it's a bent geodesic. Bent geodesics aren't doing anything. They can't do anything. They're useless. That doesn't mean anything. It's nonsense. How does the geodesic get bent? What is the physical mechanism? Where's the clock in that clockwork? There's no clock. So Einstein was a hypocrite.
I think that Einstein was actually right in this particular dispute. So let me just mention 2 reasons why the Copenhagen interpretation by itself can't be the right final answer.
I don't think Einstein had any sympathy for the many worlds nonsense either. So, I mean, Einstein was right about that too, that's even woolier. That's even nuttier. That's even more of an invisible man bullshit escapism nonsense. We'll just say everything happened, and that way we don't have to account for what actually did happen. But we'll just say everything happened. It just happened somewhere else where we can't see it. It's just stupid. The photon did go to Venus. Just didn't do it in this universe. I mean, it's just such a cop-out.
There's what we might call the reality problem. We started by saying that electrons should be thought of as wave functions, but what is the wave function really? Is the wave function a complete description of nature? In other words, is there an isomorphism between the mathematical formalism of a wave function and what reality is doing?
No, because it's way too simple and it doesn't fit. Again, there's no point in giving a Volkswagen a wave function. There's no point in saying it doesn't know where it is. It does. It has a location. The location is real, and you have to move the location by applying a real force. There's no magical movement of the Volkswagen. So this theory is nonsense. It doesn't have anything to do with reality.
Or is it part of nature, but not the whole part? Maybe there's other variables there. That's what Einstein himself thought. He thought that there was a wave function, but there were also particles. So the wave function...
I don't believe he thought there was a wave function. He just said that waves are obviously the emergent property. They obviously happen, okay, a wave of soldiers. You could say it's a wave of soldiers, but you know how the soldiers individually got to the front line. You know why they're the same distance from the fort. Okay, it's because they all left at the same time, and they all headed out to their trench at the same time, and you're all waiting for the moment to go somewhere, so they've stopped moving when they get to this line, and that's what the line is made out of. You know why there's a line. But the wave isn't some fundamental elemental function. It's an emergent function. It emerges out of the fact that you sent all the soldiers out at the same time.
Describe what happened when you weren't looking at them, but when you measure the thing, you see the actual particle. And in the modern version, these are called hidden variable theories.
Yeah, right. So this is just more nonsense that somehow the variables are hidden when they're not very hidden. Okay, they're really kind of obvious, these variables, the slits and different things. If you look for the variables, you can see the variables. Now, with the boat analogy, it's kind of obvious. If I have a boat and it has 3 guys going this way and 2 guys going that way, I can surmise that there's an extra rower out there somewhere in the ocean going that way because it's not balanced. So he's out there somewhere. So all they're really saying, if something's moving left, there's some rowers or a boat moving right. That's not too hard to deduce, is it? No, that's just so freaking obvious.
Mechanics is the most famous version. But maybe the wave function doesn't represent reality in any way. There's other people who say, just use the wave function to make predictions. Don't think of it as part of reality. So the fact is that even professional physicists who use quantum mechanics every day can't tell you what it says about reality.
Right, so this is the people we should trust, is the ones who can't even decide on a fundamental mechanism, and their mechanisms are so divergent. One says photons have radar and can do math. The other one says it doesn't matter what photons have because they go everywhere in the universe, and we just make a new universe to account for their whatever happens. So whatever happens just happens because there's a universe that has any possibility. Anything that was possible happened. It's just nonsense. Even though there was no possibilities. It's only possible because you said, instead of thinking of a photon as going through the slits and either going here, 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 we'll just say, let's just pretend we don't know. And that's all they're saying. There's a new universe for each one of those. And we just happen to be in the universe that it went straight ahead in. I mean, that's how silly it is. Doesn't account for anything.
And if you ask them, they will tell you in all honesty, bless their hearts, that they don't care about reality. All they care about is making predictions for observations. I think that's a bad attitude to have. But
again, and there's no predictions here. They have made no real predictions ever. They've made no interesting predictions, like who's going to win the election or something. There's no interesting predictions. There's no predictions about anything except stuff I could predict. I could predict that, when you do the roulette wheel thing, it's not going to come up as a 00 every time, or it's not going to be, I can make predictions. I don't need any theory or math.
I'm in the minority there. The other problem is called the measurement problem, and this one is even more obvious as a problem. What do you mean, make a measurement or look at something? Like, what counts as a measurement? Who is able to do measurements?
Well, let's just understand that measurements in this size of the universe are quite possible because you have smaller things to measure big things with. In this quantum world, in the small universe, there's no small things to measure the small things with. You can't measure them. There's nothing smaller than them. So you have no instrument, you have no ruler, you have no mechanism you have no light switch, you have nothing. You have no measuring instruments in the small universe. It's impossible to have them. It's theoretically impossible to have them. So there's every reason to understand you can't do anything called measuring, but you can't do it passively. You can't have a tiny interaction with anything on the subatomic level. There's no tiny interaction. Photons don't rub against things. Electrons don't move because the wind blew them. No, they have to have real interactions, and they're either complete interactions or no interaction. And that's it. It's all or nothing in their world, and we can't create any all, or we can't create any nothing or whatever. We can't create any electron or proton light. We can't create some light to shine on them, some passive, unaffecting source of understanding. There's no light we can shine on them, but we can see.
Is it just people? Do you need to be human? Do you need to be conscious? What about when you're asleep? Can cats make measurements? What about video cameras? What if I don't look at it very closely? What if I glance at it? Does that count as a measurement? How fast does it happen? When does it happen? A well-defined...
So again, let's go back. Do you really believe that when I turn that light off, I disappear and I change in some fundamental way? Regardless. No, it's not interfering with me. It's not affecting the outcome. Where clearly such a light would affect the outcome of where the electrons are. It's a wind to them. It's a 500-mile-an-hour wind. It's a huge wind. You can't passively interact with subatomic particles. Impossible to do.
A rigorous theory of physics should answer all of these questions, and the Copenhagen interpretation doesn't answer any of them. It just says, don't worry about that. You know a measurement when you see it. I think that's not quite good enough to be a fundamental theory of nature.
So again, the word measurement just can't mean anything. You either interact in a significant way to the process you're attempting to see, or you don't. You either hit a boulder on the edge of a cliff. You either hit it with enough energy to move it, or you don't. There's nothing in between. There's no such thing as measuring.
There are different alternatives. These days, this is all put together in the 1920s, right? These days, we actually have perfectly well-defined theoretical physics frameworks that do answer these questions. The problem is we have more than one, and we're having trouble deciding between them. So I'm not...
Well, they don't answer the question. So to sit there and say a new universe is created is not answering any question. Because you haven't explained how a new universe is even created, or how they could exist without interfering with each other. You haven't explained anything, because you created some new abstract. It's like saying dark matter explains something when it doesn't explain how matter exists in this new form that doesn't reflect anything and that is completely invisible to everything except gravity and blah, blah, blah. It doesn't explain anything. The invisible man doesn't explain anything. I use that as an excuse for an event. I haven't explained a damn thing. I found an excuse, an evasion. I haven't found an explanation.
Not going to be in any sense fair in this talk. I'm just going to tell you my favorite one and let you know there are others. Buy the book if you want to see the others. Okay. Here's my favorite. It came from Hugh Everett, who was a graduate student and it was incredibly criticized for his ideas, and it left the field right away.
Yeah, but it might as well just be religion. It's just a God of the Gaps bullshit answer. It's just saying, oh, gee, there's no, there's no, what do you call it? Missing link. You know, there's no. We're missing the skeleton evidence. Where's the evidence for evolution? It's missing. So it must not work. So, we'll just make up a God theory. I mean, it's really terrible to sit there and say you need to create new universes to explain something that just has a tiny bit of complexity or nuance to it. Again, all they can't explain is why does an electron have motion or energy? Why is it expelling energy? Why is it a light bulb? When the simple answer is it's not a light bulb. This is not a light bulb. This is not producing photons. It's reflecting them. Because they can't do that, they have to resort to creating universes. Because they can't understand the difference between a thing reflecting a force and one producing a force. They have to create new universes.
And so Hugh Everett says the following. He says, here's the solution to all of your quantum problems. Chill out. Stop working so hard. You're trying too hard.
Because they can't understand this absorbing energy and going this way, and that meaning there's an equal and opposite effect in the universe, that there's stuff going that way. All right, you just don't see it, but it's there. Because for this to go this way, it had to absorb stuff going that way, and that means that there's more in the field now. There's less this way because it's inside of here, and there's swimmers, and there's more swimmers going that way now because they're in this boat. The ones going this way are in the boat. The ones going that way aren't in the boat.
With all this stuff, you've made up a whole separate set of rules about quantum mechanics for what happens when you measure or observe a system. Just erase all those rules. Just forget about them. You want to know what reality is? It's the wave function. You want to know what wave functions do? They obey the Schrödinger equation, and that's it. That's all you need to know.
And let's understand, wave functions are just synthetic nonsense made up where you say something doesn't discretely go through something else, and instead it goes everywhere. And now you have to explain how it went everywhere but only landed in one location. And the way you're explaining why it's in one location is you're just saying you happen to be in the universe where it went this way. It went that way in some other universe, and went that way and that way. And so you're just making up new universes to account for where something went. When, again, logically we know this didn't split into two things, and it didn't go in two directions, and none of that happened. And it certainly didn't interfere with itself.
So in other words, this is the Everett interpretation of quantum mechanics. There's only one set of rules. They're always obeyed, and all it says is they're wave functions obeying the Schrödinger equation. Now, there's a problem with this interpretation, which is why it was not invented by Bohr or Einstein in the 1930s.
Because they got laughed at.
But it doesn't seem to quite map onto our experience, right? Like we saw the cloud chamber with all the little particles moving. They don't look like they're obeying Schrödinger's equation, so what's going on? And Everett says there are two things that you've forgotten about that are already built into quantum mechanics. He doesn't add anything, right? He erased some rules. And
the rule is just that we're stuck in one perceptual universe. That is, we've had, just as you have one set of ancestors, and that's the only set of ancestors you have, that's the way yours came out, but it's not the way all the others are coming out. So all the others are connected in that one point. You could say in one point in time all the universes are in the same place, but they go somewhere else. I mean, I don't know how to even say that. I mean, obviously they all can't be in the same point in one time. I mean, if the photon goes to Venus, it can't go over here, and it can't create a whole bunch of other stuff that happened over here. So all of the stuff that happened this way can't possibly be connected to that stuff there. So that universe is fundamentally different. He says there are two things that are already there in quantum mechanics that if you just take them seriously, everything will be fine. One thing is you yourself are a quantum system, right? You are part of the wave function of the universe. You are not a class. Well, there's no point in calling you a you, though, because you don't interact with the rest of the universe as a you. You interact with the rest of the universe as a bunch of individual cells, and then those individual cells are individual atoms. And you are interacting in the universe as individual atoms. The individual atoms are bound to individual atoms. They're interacting in the universe. Their functions are static and controlled by the force effects of the combined structure. And but you are not relevant. You're emergent. You're not elemental. The elemental bits are deciding what you are. Everything I'm doing here is happening on a subatomic level. It's not happening on this big level. It happens first in the little universe. The little universe makes the big universe. The big universe doesn't make the little universe. It's bottom up, not top down. So again, it makes no sense to talk about a you. You will not interact with the world. I can stick my finger in a fire. I didn't interact. My finger interacted, and then the neurons interacted, and different things interact. But some things my feet won't know anything about it. They won't give a shit. I mean, this is just such crap. All right, it's probably enough. I won't go on and on, but I mean, there is more to go on and on about. But again, this all just relates to the fact that the simple problem, right? The battery's giving off light. It's creating photons. I see them. There's photons coming off this battery. Therefore, how does the battery stay? How does the battery do anything? Where's the energy coming from? Why is the battery getting smaller? It's producing all these photons. Where are all these photons coming from? Where's all this energy coming from? A simple explanation. It's coming from somewhere else. And that explains gravity, explains magnetism, explains everything. Magnets aren't creating anything. They're just reflecting it different. One end's reflecting, one end isn't, doing exactly the opposite in terms of what it's reflecting. What comes in, different stuff comes out. Different stuff goes through. That's all it's doing. The two charges are two different kinds of reflector. One reflects one light, the other reflects the other light. That's it. No more complicated than that. And it doesn't come from in here. The magnet's just a filter. This is pathetic. But anyway, this is so silly. But again, it's really that simple. They're sitting here and they're saying, where's it coming from? Where's the energy? Where's the energy? Now, they never asked that about gravity, but here they are saying, where's the energy coming from the electron? The electron's not doing anything the field isn't making it do. And it's doing it when it moves. Why do you think it moves? What do you think happened to the energy? Well, the energy has to be inside of it. The shuttle takes off, goes up through the atmosphere. There's a big giant flame at one end. What do you think is inside the shuttle? Do you think there's something opposite, something fundamentally different than a big pile of energy going into the shuttle? A bunch of rowers sitting in the goddamn boat? Same difference. If a bunch of rowers are flying out the back end, free, then what do you think's happening in the shuttle? Well, what's happening is a bunch of rowers are getting in the seats, and those are the rowers getting thrown back out into the fucking ocean. It's really that simple. You absorb force. You trap it. And it moves you much, much slower than the speed of light. And so the force that was going somewhere at the speed of light doesn't get there because it's sitting in your slow fucking boat. So if we gave all the rowers a number, and number 500 jumps into the boat, well, number 500, if he didn't jump in the boat, was going to be here, and then he was going to be there, and he's going to be all kinds of places. And now he's not going to be any of those places because now he's in a slow fucking boat. But if a bunch of others, like 501 and 502, and a bunch of other rowers jump in that boat starts moving pretty fast, then when it actually gets to the earth and crashes into it, there's going to be a whole bunch of rowers flying out. Anyway, shit. It's just too stupid. But there's not more rowers, don't get me wrong. It's just that they're all going in the same direction. And when a lot of stuff is going in the same direction, that means all the stuff it has contact with has to go in that direction. And changing direction breaks complex matter. Complex matter doesn't like doing this. Okay? If complex matter had to vibrate like like a violin string or something, some big piece of matter, the big piece of matter would fly apart. It's just... Anyway. People are just trying not to get the right answer. They're just trying not to. That can be the only explanation. You can't be this dupable and foolable and go to these extreme, desperate answers of multiverses unless you're trying.